Section 8.4, Identifying Transformations. Remember that there's three different types of transformations. A translation, which is a sliding over and up or over and down. A reflection, which means you make an exact opposite copy, but you got to have a mirror reflection line right there. So it looks the same on both sides, but it's opposite. And a rotation, which means you turn it either counterclockwise or you turn it clockwise and rotate it, and you got to have some point where it rotates on. Okay, so you've got the transformations right here in this one. Let's look at square A. Square A would be this one right here. So square A is the image after square X is translated. So here's square number, okay, there's X, and there's A. It's translated, or you slide it, 4 units right. So 1, 2, 3, 4 units right, and then 4 units up. 1, 2, 3, 4. Okay, so they used to call them slides years ago, but you could make that image by sliding it over and up 4 units. I usually like to pick one point on this one, and then just follow that one point and see how many it goes up, because all the rest of them got to still be in the same spots anyway. Looking at square B over here, this one is the image of square X. In other words, it's an exact copy, except it's reflected using this dotted line right here as your mirror line right here. Okay? So every one of them, this point is the same as this point, and this point is the same, and of course this point here and this point here is the same. So they should all be the same distance from the mirror line, but opposite directions. Looking at this one here, square C, okay, that's the middle one here. Square C is the image of square X after a rotation of 90 degrees clockwise about point P. So whenever you're doing a rotation, you've always got to pick a point to rotate on. So if I'm going to rotate 90 degrees is a perfect corner. So if my point is there, my point should rotate. If it's counterclockwise, my point should be right there. If it's counterclockwise, I've got to go and rotate it this direction, and the point should be right there. So looking at this one here, there's C. Point P is down here, so this is the one that's rotating. Okay, and there's the X is rotating clockwise, so I'm just going to follow this one. It's going to rotate 90 degrees, which would bring it right up to there. That's a 90-degree rotation, as you can see, and it's clockwise. Square C is also the image of square X after a rotation of 90 degrees clockwise about point Q. So here's the point. You're always looking for a certain point when you're rotating. And square C is the image. So this guy here is the image. Okay, don't need this point anymore. So C is the image right here. And it's been rotated 90 degrees counterclockwise about point Q. So if I were to kind of take this line here, this one should shift all the way up and be facing this way. So it rotates this way. So I always like to pick one point or one line on the image and just see how much it rotated in terms of its degrees. So I'll give you a quick example of that one. If I were to make a lovely looking rectangle here, okay, and let's say this is my point I want to rotate upon. So let's say this is point P. If I want to rotate him 90 degrees clockwise, well, remember clockwise goes this way. Okay? So if I want to rotate him 90, I could follow this line here, and this line right there should be facing 90 degrees clockwise would be this way. So now this here this here rectangle should be 90 degrees about point P. So it should be looking like that. That would make it a 90-degree rotation clockwise. Okay, so I'm still following that same line. This is the line that rotated. And as you can tell, this is a 90-degree turn. Okay, looking at a couple more. Square D, and if we look at square D, that would be this one right up in the top corner right here. So square D is the image of square X. So here's square X. After a rotation of 180 degrees about point Q. So in other words, it totally flipped around by rotating it the other way, the opposite way. So if this is the line here now, flipping it 180 degrees should be going in the opposite direction. So here is the same line. And it doesn't matter whether or not you go clockwise or counterclockwise when you rotate 180 degrees, because no matter what, you're going to end up in the same spot. So if I'm starting here and my line is, well, maybe even better line than that. If I want to rotate 180 degrees clockwise, it's going to end up there. If I want to go counterclockwise, it's still going to end up in the same spot. Okay, so 180 degree rotation just means it's going to totally rotate around and face the opposite direction. And that's a couple of things made down here on this point. Down here, a rotation of 180 degrees clockwise gives the same image as a rotation 180 degrees counterclockwise, about the same point. Okay, moving on to the next section. Section 8. Oh, there we go. Section 8.5, constructing tessellations. Now this is the last section in this unit, and it's probably one of the easier sections too. What we're saying is when an object tessellates, when some shape tessellates, it basically means you're putting together the same shape. Okay, so in this case it's a triangle. Oops, right there. So here's our triangle. You're putting together a triangle together, and there should not be any overlaps or gaps. Okay, so when you put them all together, you notice there's no gaps, there's no overlaps, there's nothing. It goes together perfect, kind of like a puzzle. In this one here, this one goes together perfect as well. Okay, so where they meet, there should not be any gaps. In this case here, looks like there's a gap here, so that's no good. That does not, or is not tessellating here right now. Doesn't look like it is anyway. So whenever you have shapes, if it goes together, that means they are tessellating. One of the ways to tell if an object is going to tessellate is that all of the angles that go together should add up to give you 360 degrees. Okay? So, for example, if I were to make a shape here now, and I know that's a 90-degree angle right here. This is 90 degrees. Okay? Now, when I put them all together, if I keep making a bunch of these shapes right here, and maybe I'll write 90 on it. So this is 90 degrees here. I don't know what these two are, okay? But I'm going to take that and make a few extra copies. Okay, copy, and let's paste 3 more. So I'm going to take him, and I'm going to put these 90-degree angles together. So I'll put this one together, this one together, this one together, like that. There we go. Okay, and of course I could take then this one, and I can put him together just like that. And you notice where all 4 of those angles are together here, it basically goes right around almost in a circle. So 90 plus 90 is 180, plus another 90 and 90 is 360 degrees. So you can tell if it's going to tessellate by just looking at the angles that make up the interior. If they don't add up to 360, then it's not going to tessellate. Just about every triangle that you can see here will end up tessellating, and just about every quadrilateral will end up tessellating as well. So I could take a square, that's a pretty common one. I could take this square here And if I keep putting them together, you know that every square is 90 degrees for each angle. So you know you can put 4 of them together to make 360. I could take another quadrilateral, maybe something like this, 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 maybe right there, and right there. Now I can try to put that together once I join them together. There we go. Now I'm going to make a few of them and see if they're going together nicely. So I could take him, and it might take a little bit of flipping them around sometimes to get them to go just right. But as long as I can get them to go together, there we go. Let's take another one. Now I've got to decide where I'm going to put these. Let me see, how about right there? Oops. I'll rotate them around a little bit more. And you can see what's starting to happen here. We're getting all of these to go together. And you can tell that it is going to tessellate. There's no gaps, and all 4 of these angles here, 2, 3, 4, will add up to 360 degrees. So we know that this one will tessellate. And I can keep going and going and going, and it will eventually make a perfect tessellation. A little test for that, and the reason why this will work, well, let's give it a test up here. Let's take our same shape and paste it right there like that. And let's just have a look at some of the angles here in this one. So if I take a protractor here, there we go, and I go ahead and I might blow this guy up a little bit bigger so I can see him. There we go. Now if I start measuring the angles here, this angle I already know is going to give me a 90-degree angle. That one looks like a 90-degree angle. So we'll put 90 down there for this corner. Oopsie daisy, too big. See if I can shrink him down. My goodness. Okay. And then I test this one right here. Move him over. And I gotta make sure I got him done right. That one looks to me roughly 70, maybe 68, depending on how accurate my measurement is. Okay. So 68. Try this guy again, right up here. Now, this one looks like about 130. So I'll move him again. 130. And this final angle right here. Let's see, I'll probably have to measure him upside down here to get a good measurement. And then just a little, there we go. And this one here looks roughly about 68 again. So probably closer to 70 if I had measured him even more accurately. So this one looks like 70. This one looks like 68 or 70. Okay. Now, if you add them up, you've got 130, you've got 70, you've got 70, and you have roughly what looks to be a 90-degree angle. So adding them all up, 7, 8, 9, 10, that would be 17, and that would be 28. There we go. So 9, 16, 17, 18, 19. Oh, sorry, 26. and then you got 2 and 3 is 360. So all four of these angles of the quadrilateral will add up to 360 degrees. Now, that's if you didn't remember that. All four angles of a quadrilateral will give you 360 anyway. So you know by putting four of them together, just put four opposite ones together and you should end up with a 360 degrees. All right, kind of a long way to go about it, but that just kind of proved that all four angles are equal to 360 degrees. So whenever you're given some of these ones, the easiest way to see whether or not it will tessellate, you have to go ahead and see if you can make 360 degrees using any of the angles that you put together.